Hello, welcome to Hidden Gems. My name is Arden Thomas. I'm the Cincom Smalltalk product manager. If you have any comments or suggestions, please send them to me, athomas@cincom.com. It's right here. So today we're going to talk about another hidden gem that has to do with very large collections or big collections. We're going to discuss a class called LargeArray. LargeArray really qualifies as a hidden gem. It's not really known, and it's a little bit different, so we're going to educate you on where and how you can use that. So let's get started. The first thing to know about LargeArray is that it is not a replacement for array, but it's extremely useful once you know the rules about how to use it and where you might use it and why. Let's come over here. I'm going to Control E to open a browser on LargeArray. And this says it's specializes a segmented collection to act as an array. Well, that's partially correct. It doesn't actually act 100% as an array, and that's where you need to be careful. But segmented collection breaks up how the things are stored, and we'll discuss that more in a moment. So let's first show one thing. Let's create an array, LargeArray new 10. I'm going to execute that. Now, if I inspect this, I'm seeing something a little different. Okay, this is a page of 256 elements. LargeArray adds capacity in pages of size 256. So what that will mean in the implementation, though, is if I say from 1 to 10, put that number there. Here's one of the caveats. So test array do, transcript show each. So you'd think, oh, we're going to show 1 through 10, right? Well, yes, but then we also show everything else in that page, which it iterates through. So it will iterate through all the items in all the pages. In this case, I've got one page. Now, where this is really useful is, for example, how it's used in the system. If I look at examples, references, it's used right here as a map to map Unicode characters. And if I inspect this right here, it's a LargeArray. And the nice thing about LargeArray is if everything in a page is nil, it doesn't store it. It basically just has each of these pages referring to the same thing. Or if a page is identical, it has things in it, but it is exactly the same as another page, it doesn't reproduce that page. Both will reference the same page. So in that effect, it's like a sparse array. It conserves space. So we can see there's lots of empty space here. So this is a great choice. But where we do have them, we have a page with values. So this is a great way. 256 times 256 is 65,536, or every possible combination in a word. So that's where it's really useful for, saving space. But what else is it useful for? Well, let's talk about some of the advantages. So one of the first big advantages is massive contiguous arrays are harder to allocate and more difficult to garbage collect. So basically blocks of 256, pages of 256 are much, much easier on your garbage collector. The next thing I already mentioned is it optimizes identical pages. So it doesn't reproduce those. It basically references one copy if they are identical. So let's experiment a little here. Let's create a LargeArray of 10 million. I'm going to go ahead and do that very quick. And then at each element, I'm going to put that number. So basically, all my positions will be full. If we look at that, I can see exactly that. Each of my pages are full with numbers in that page. So the advantage here is it can't use this as a sparse array because all the elements are full. But what it does do is it breaks them up into pages, so the garbage collection can move things around and garbage collect appropriately. Because if I have one contiguous block of 10 million or 100 million or a trillion, it's going to be much, much more difficult on the garbage collector. Other things to be aware of, let's take this large array and notice what I have here. If it's nil, do nothing. If it's not nil, I'm going to add 5 and I'm going to collect those. And if I inspect the results of this, it's going to be an array because large array is a kind of array, so it returns an array. And this is an array of 10 million objects. So what if I don't want that? What if I want the results also in a large array? I have to specify that. So I'm going to create another large array called large array results. Go ahead and do that. And then I'm going to do with index here. I'm going to say the results at I, that's my index. I pass in, put each item, and I add 5 to it. So I can do that. Now I can look at, inspect large array results, and I have essentially, I've added 5 to each element, but it works that way. I've got a large array which has the advantages of large array, particularly in respect to garbage collection. So let's do a quick recap. Large array, it's not an exact array replacement, but great once you know the rules. For massive contiguous arrays are more difficult to garbage collect, so this does it in pages of size 256, which are much easier to garbage collect. And it also optimizes identical pages, so if you have examples that are sparsely storing in your massive array, this is an excellent solution. And you have to be aware the iteration will go through all the empty items in the pages and out to the end of the last page, whether you specified that amount or not. So what are the trade-offs? Well, you definitely get performance in garbage collection and space allocation. You do have another level for lookup because you have to look to the page, you have to find the page, and then within the page, rather than going directly to direct access to that array. So that's a small time penalty in lookup. So should you use it or not use it? My tip is benchmark both ways. If you have something very large, if you think if it's very sparse, this might be a great, a great replacement to use in that case for the array. And in other cases, you want to benchmark it. You want to benchmark it and consider other things like, is this array fleeting? Like I'm going to create it for a few seconds and then throw it away, or I'm keeping it forever and it's really not going to be updated and it's sparsely used, which is how we use it for the map that you saw for mapping Unicode characters. So that's it. Large array. Any questions, comments, suggestions? Please send them to myself, Arden Thomas, athomas@cincom.com. Until next time, have a great time with Cincom Smalltalk.